Hello, in this fluid mechanics class, we will discuss about dimensional analysis. This is first class of this chapter or this module, dimensional analysis. It is a mathematical technique used to research work for design. The fundamental fixed dimensions are length, mass, and time. So, length L, m is mass, and time is t. So MLT are the fundamental dimensions. Now the second topic is secondary quantity. Secondary quantity. So what is secondary quantity? Secondary quantity are those quantities which possess more than one fundamental dimensions. Okay, which possess more than one fundamental dimensions. Let us this is an example. Force is a secondary quantity. So force equals to, we can write force equals to mass into acceleration. So force equals to mass is a fundamental fixed dimension, so we can write m. And when we consider acceleration is length per time square, so L by t square. So finally force equals to m L and t inverse 2. So force equals to ml t inverse 2. So this is the secondary quantity. Now we will discussing about dimensional homogeneity. What is dimensional homogeneity? In the method of dimensional analysis are based on the Fourier principle of dimensional homogeneity. The principle of dimensional homogeneity is greatly useful in asserting the form of equation involving physical phenomena from its relevant variables and their dimensions. Okay, now when we define dimensional homogeneity, what will is it? An equation is said to be dimensionally homogeneous if the form of the equation does not depends upon the units of measurement. If the form of equation does not depends on the unit of measurements, that equation will called dimensional homogeneous equation. Now dimensional analysis, it is a very powerful tool in formulating problem of physical phenomenon which really analytical solution and must be solved experimentally. It helps to obtain the maximum information by minimum experiments. Now assumptions. Assumptions number A. Certain variables which affect the phenomenon are called independent variables, and other than this variable is called dependent variable. So in equation there are two types of variable. One is independent and another is dependent. And number c is the total number of variables influencing the problem is equal to the number of independent variable plus 1 1 being the number of dependent variable. So in problem there are one dependent variable and other variables are independent variable. Okay, and number D is the dimensional analysis is used to obtain a functional relationship between dependent and independent variables. Okay.
So omega equals to rho into G into V. Now omega equals to, when we define density, that is mass by volume. Density rho is equal to mass by volume, and G is the acceleration, gravitational acceleration. So it is nothing but an acceleration. So distance by time square, and the last one is V. V is volume. It is a product of three linear dimensions. So L into L into L, that is nothing but volume. So in this case, mass is fundamental dimension, so m, and volume is L cube, L into L into L, that is nothing but L cube, and distance is nothing but a linear dimension, so we can write L. Time is also a fundamental dimension, so we can write T square, and this is also volume, so we can write L cube. Now the next line, m, L and by T square. So when we modify this equation, it becomes weight equals to m L T inverse 2. Now next example is kinematic viscosity. It is denoted by nu. We know in last class we have discussed about kinematic viscosity, dynamic viscosity, density, everything. By the way, what is kinematic viscosity? Kinematic viscosity is the ratio of dynamic viscosity by density of fluid. Now, what is dynamic viscosity? Dynamic viscosity is denoted by mu. So dynamic viscosity is mu equals to, it is the ratio of shear stress by velocity gradient. Again, shear stress also denoted by tau, and velocity, what is velocity gradient? The change of velocity with respect to depth. Change of velocity with respect to depth is called velocity gradient. This velocity gradient is also elaborated in last class. So we know everything. So mu equals to shear stress by velocity gradient, that is tau by du dy. Now if we find out the dimension of kinematic viscosity, we have to first find out the dimension of this particular portion. So tau, it is nothing but a stress. Now what is stress? Force by area. Force by area is called stress. So F by A. Then what is F? I mean, what is force? Force is nothing but mass into acceleration. So mass into acceleration. Mass is a fundamental fixed dimension. So from m we can write m, from mass we can write m, and from acceleration, what is acceleration? Distance by time square. So distance is nothing but L, length, and by time square, that is also a fundamental dimension, so this is T square. So acceleration is L by T square. So then F is force. Force equals to m L T inverse 2. Okay, this is dimension of force. Here stress equals to force by area. Now we have to find out area. Dimension of area. It is very simple. Area is a product of two linear dimensions. That is A equals to L into L. That is length into length. So it becomes L square. Now, so we find F and A. So F and A. So it is now we have to find this tau. So tau equals to F. Dimension of F equals to MLT inverse 2. We are putting this value and F by A and putting the value of A here. Putting the value of F here and putting the value of A here. And ultimately the dimension of stress become M L inverse T inverse 2. Now tau is known for us. The dimension of tau is known for us now. So we are putting the value of tau here because mu equals to tau by du dy. So mu equals to division line. Above the division line we are putting the value of tau, m L inverse T inverse 2, and here we have to putting the value of velocity gradient. Velocity gradient is the ratio of u and y. So u is here, u is the velocity. So what is velocity? The definition of velocity: distance by time. So distance is nothing but L length. So L by T, and y is linear dimension. So here we can write 1 by L. From this we can also easily find out the mu m into L inverse into T inverse. This is the value of mu, or this is the dimension of mu. Now we are also find density. What is density? Density is mass by volume. So mass is a fundamental dimension. We can write m, and volume, it is a product of three linear dimensions. So we can write L cube. So the dimension becomes of density is ml inverse 3. Now what is ultimately kinematic viscosity? Kinematic viscosity nu equals to mu by density, mu by rho. Now above the division line we are putting the dimensions of mu, and here we are putting the value of or the dimension of rho. Then ultimately the dimension of kinematic viscosity, that is nu, equals to L square T inverse. Procedure step 1. In the dimensional analysis is to decide which variables enter the problem. Which variable enter in the problem. The naming these variables which affect the problem requires through understanding of the phenomena, and is a matter of judgment and experience. Okay, and second step is formation of dimensionless group of the variables. Second step is very important, that is formation of dimensionless group of variables. Now there are two types of there are two methods for finding out dimensional analysis. Number one is Rayleigh's method, and number two is Buckingham Pi theorem. Buckingham Pi theorem is very useful theorem or method for finding out the dimensional analysis. By the way, we have to decide, we have to discuss about two methods. Number A, Rayleigh's methods, and number two, Vacuum-Python method. At first, we are discussing A, Rayleigh's method. From the principle of dimensional homogeneity, it is apparent that the variables involved cannot be added or subtracted. Okay, since their dimensions are different. Because of difference of dimensions. This principle limits the equation to be combination of product of powers of variables involved. Okay, this is very important. This principle limits the equation to be combination of products of powers of variables involved. Let's do a problem for understanding the Rayleigh's method more easy. In this problem, the drag force D experienced by a shape having a characteristic length L and moving with a velocity V depends on the fluid mass density rho and viscosity mu and acceleration due to gravity is g. Now, using Rayleigh's method for expression for D. Now, when a ship moves in a sea, it experienced some difficulties. That is its length is really a factor when it's moved in a sea, and the velocity of the ship is also another factor, and density of fluid, that the density of the seawater, it is also essential factor. We have to considering these factors because we are studying fluid mechanics. Viscosity of that fluid, it is also considerable, and acceleration due to gravity, this is also considerable. Now, these all are variables. Now we have to find out the functional relationship between these variables. We have to find out the functional relationship between these variables. So D is a variable, L is a variable, V is a variable, rho is a variable, mu, G, everything is variable. Now we have to find out in this variable which is independent, which are independent, and which is dependent variable. In any problem there are only one dependent variable, others are independent variables. So we have to find out at first. So it is a very simple thing to find out in this case, that the drag force is a single dependent variables which depends on these independent variables. Which independent variables? That characteristic length L, velocity of the shape V, density of the water or fluid, say water, density of the water, viscosity of the water, gravitational acceleration G. So these all are independent variable. Only one dependent variable is drag. So this is very essential to find out the functional relationship between all variables. Okay. Next, is we have to find out each variable. So sorry, we are next we have to find out the dimensions of each variables. That drag force is nothing but a force, so mlt inverse 2, characteristic length is L, velocity is L t inverse, density is ml inverse 3, viscosity is ml inverse t inverse, and gravitational acceleration is, it is nothing but an acceleration, so it is L t inverse 2. Now we have to develop a equation, that is D equals to C into L to the power x, V to the power y, rho to the power z, mu to the power r, and g to the power s. Which is C? C is the dimensionless constant. C is dimensionless a constant, and we have to put a power in every independent variables. L is independent, V, rho, mu, g, everything is independent, so we have to put powers. In L we are putting x power, in V we are putting y, then in rho we are putting z, and mu we are putting r, and gravitation action g we are putting s. This is equation number 1. And now for dimensionally expressions, we are converting these variables into dimensionally expressions. Okay, so what is the dimensions of D, that is drag force, mlt inverse 2, so we are putting here, we are putting the dimensions of L, we are putting here the dimensions of velocity, we are putting here the dimensions of viscosity, and we are putting here the dimensions of gravitational acceleration. Now next we using the principle of dimensionally homogeneity, here three numbers equation for exponent of mlt. Okay, three number of exponent, that mlt. So when at first we are considering m. Okay, m. In this equation, this part is left hand side and this part is right hand side. In left hand side, in this equation of left hand side, the power of m is only 1, so we are putting 1 here. Okay, then equals to, then we have to find out where is m, because this is m expression. Here is no m, here is no m, here is m. Where? In density, ml 3 inverse. Here the power of m is 1. Okay, and overall power is z, so 1 into z, ultimately z. So the power of m become z, and we have to find out we have to find out the next one, where is m. And in the viscosity, where we are finding m, we are already find that there is m. In this case, the power of m is here r, so we are putting plus, because there are no inverse sign above the m, so we are putting plus r. Okay, now next equation L, in left hand side, the power of L is 1, so we are putting here 1, equals to in the right hand side, the power of L in this case, there is X. In next, there is Y, plus Y. So we are putting plus Y. In next, there is the power of L is minus 3Z. This is 3 minus 3 and this is Z. So it becomes minus 3Z. Next, we are finding in the right hand side, where is L? This is L. It is also minus 1 and this is R. So the power of L here, the power of L is minus R. We are putting here minus R. Then the last, we are considering this L, so this is plus 1, so we are and the power is S, so we are putting here plus S, as it is in the case of T. In the left hand side of the equation, we will see that there are T of power minus 2, so we are putting here the power of T minus 2 equals to, in the right hand side we are considering this T, so the power is minus Y, so we are putting here minus Y. Then here there are minus R, so we are putting here minus R. Then there are minus 2S, so we are putting here minus 2S. After find out the three equation for exponent of M, L and T, that is M, L and T equation, we are solving the above equations. From this equation, 1 equals to Z plus R, we are getting Z equals to 1 minus R. After that, the equation of L, 1 minus X plus Y minus 3Z minus R plus S. We get this equation, y equals to 2 minus R minus 2S, and last one is X equals to 2 minus R plus S. We are after solving that equation, we are getting this formation. Okay, now putting the values in the equation number 1. Now this value, we are getting the value of X, Y and Z. We are getting X, Y and Z. Now in equation number 1, in this problem, we are considering that D equals to C is a constant, dimensionless constant, into L to the power X, V to the power Y and Z to the power Z, rho to the power Z, and mu to the power R and G to the power S in equation number 1. So we are putting the values of that powers in equation number 1. Then in the equation number D equals to C, C is dimensionless constant, then L to the power X. So what is the value of X? Here we see the value of X is 2 minus R plus S. So we are putting the value of X here. The next value is Y. Power of V is Y. So we are putting the value of Y here. And rho, the power of rho is Z. So we are putting the value of Z here. And after that, mu and G, the power of mu is R and the power of G is S. So it is the we are putting the value of putting the value of the powers X, Y, Z in equation number 1. After grouping the term, we will get this formation. How? this is D equals to C. Okay, then in this equation the power of rho, here the power of rho is 1, and here also the power of rho is minus R if I split up it. So at first we are considering only that case, we are not considering the power R power or S power, we are considering numeric power. So here we are see that the power of rho is +1, so we are putting here rho +1, so it is not, the power is not shown here. Then after that we are putting the L, the numeric power is 2, so we are putting the L with the power of 2, so it becomes L square. Then in this equation we are find the V, there is V, the power of the power of numeric power of V is 2, so we are putting here V square. Okay, now we are grouping in two formation, that is one is minus S and one is minus R. Okay, in this minus S group we are see the V square. So where is V? There is V. Okay, V, and this is minus 2S, so the power of S, so become V minus 2S, so we are putting here V square, and minus S is out of the bracket. Okay, and after that we are finding the power of L and G. So this is G and this is L. The power of L is +S, so it is below the division line L. Okay, and this is also the power of G is +S, so it is also below the division line, because we are considering negative power in above the division line. Same as it is happen in this grouping minus R. Say mu, this is mu to the power 1 is already put it here, so the rest part of the mu is minus R, so it is putting here above the division line. Okay, after that V, this V power is minus R, only minus R, minus 1 R, so we are putting here minus R. Then L, this is also L, the power is minus R, so we are putting here L. And the mu, we see the mu is mu to the power plus R, so it is under the below the division line. Okay, so this is the functional relationship between D and others independent variables. Okay, now recognize the dimensionless group. This term is nothing but a Froude number. According to Froude number, V by root Lg, so there is V square by Lg, so this is nothing but a Froude number. And this group also Reynolds number. According to Reynolds number, we know rho VL by mu, so here is rho VL by mu. So ultimately drag force is a function of Froude number and a Reynolds number. So ultimately D equals to, we can write D equals to rho L square V square, this part rho L square V square, and function of Reynolds number and Froude number. Thank you. See you next video in Buckingham Pi theorem.